Hello everyone, welcome back to the channel OS Academy. Today we are going to talk about prompt chaining with LangChain, which is one of the most important concepts if you want to build real-world AI applications using large language models. If you have ever wondered how chatbots, AI assistants, or complex GNI systems perform multiple steps intelligently, this video is for you. What is prompt chaining? So, first, let's understand what prompt chaining actually means. Prompt chaining is a foundational concept in building advanced workflows using large language models or LLMs. Instead of using a single prompt, we link multiple prompts together in a logical sequence where the output of one prompt becomes the input for the next prompt. This modular approach is extremely powerful for solving complex tasks such as multi-step text processing, summarizing, question answering, sentiment analysis, and many other NLP workflows. In simple words, prompt chaining helps us break a big problem into smaller intelligent steps. Why LangChain? Now, managing multiple prompts manually can quickly become messy. That's where LangChain comes in. LangChain is a versatile framework designed to simplify the creation of prompt based workflows. It provides tools to manage large language models like IBM Granite models or OpenAI GPT models, define reusable and structured prompts, connects those prompts into reusable chains. By abstracting away the complexity of prompt orchestration, LangChain allows developers to focus on problem solving instead of plumbing. What you will learn in this tutorial. In this tutorial, we will explore different types of prompt chaining, implement a real chaining example, combine sequential, branching, and iterative chaining, use LangChain's built-in classes like prompt template, LLM chain, sequential chain. How LangChain manages prompt chaining. LangChain provides a powerful framework for building modular workflows, especially for chatbot and GenAI applications. Here's how LangChain manages prompt chaining effectively. Prompt abstraction. LangChain uses prompt templates to design structured input and output workflows for each step. This makes it easy to manage complex operations without rewriting prompts again and again. LLM integration. LangChain integrates seamlessly with multiple LLM providers such as IBM Granite, OpenAI, Hugging Face. This allows you to fine-tune workflows based on your use case. Chain management. LangChain provides tools like sequential chain, simple sequential chain. These allows you to connect multiple prompts into clean modular pipelines. It also supports output parsers for structured outputs like JSON. Dynamic workflows. Using tools like conditional chain and system message templates, LangChain supports adaptive workflows aligning well with RAG or retrieval augmented generation pipelines. Types of prompt chaining. Prompt chaining supports different workflow patterns. Let's go through them one by one. Sequential chaining. This is the most straightforward type. The output of one prompt is directly passed as input to the next. It's ideal for linear tasks. Branching chaining. Here's a single output is split into multiple parallel workflows. Each branch processes the data independently. Iterative chaining. In this approach, a prompt or chain runs repeatedly until a condition is met. This is useful for refining outputs. Hierarchical chaining. A large task is broken into smaller subtasks. Lower level outputs feed into higher level tasks. Conditional chaining. The next step is chosen dynamically based on previous outputs. This allows decision making inside workflows. Multimodal chaining. This integrates multiple data types like text, images, or audio. Dynamic chaining. The workflow adapts in real time based on outputs or conditions. Recursive chaining. Large inputs are broken into chunks, processed individually, and combined. Reverse chaining. You start with the expected output and work backward to determine the step. Each type is useful depending on your task complexity and requirements. Use case. Multi-step text processing. Now let's look at a real world use case. We'll process customer feedback using chat models and prompt engineering to build a scalable text processing pipeline. This workflow demonstrates sequential chaining, branching chaining, iterative chaining. Step 1, Keyword extraction. In the first step, we extract keywords from user feedback. The input text is processed through a prompt template that identifies significant keywords. This step uses sequential chaining, ensuring that the extracted keywords are passed directly to the next step. Step 2, Sentiment summary. In the second step, the extracted keywords are passed into a chat model. The model generates a sentiment summary based on those keywords. This is where branching chaining can be applied, allowing multiple summaries or analysis to run in parallel if needed. Step 3, Sentiment refinement. If the sentiment summary doesn't meet quality criteria, it is passed to a refinement prompt. This step uses iterative chaining, meaning the output is refined repeatedly until it reaches the expected precision. Final output. The refined sentiment summary is delivered as the final output. This provides polished insights, clear sentiment evaluation, actionable feedback. This showcases the power of combination prompt engineering, generative AI, and advanced chaining techniques. Prerequisites. To follow this tutorial, you need an IBM Cloud account, a watsonx.ai project, access to Jupyter Notebook. Environment setup. You will log into watson.ai, create a project, generate an API key, and launch a Jupyter Notebook. This environment will be used to run all LangChain code. Installing required packages. We install LangChain, LangChain IBM. This code installs upgrades the PIP package manager. This installs the LangChain and LangChain IBM packages. These packages are likely being used for prompt engineering tasks, possibly involving IBM's language models or services. Importing libraries. We import Watson X LLM, prompt template, LLM chain, sequential chain, and utilities like OS and getPass. This code imports necessary libraries for using IBM's Watson X LLM with LangChain, sets up a prompt template for custom prompts, and initializes an LLM chain for running the language model. It also includes a password prompt for secure access. Setting up credentials. We securely provide Watson Machine Learning API key, project ID, service URL. This code sets up the credentials and project ID for accessing IBM Watson Machine Learning WML service. It securely prompts the user to enter their API key and project ID either from environment variables or directly from the user. Initializing the LLM. We initialize the IBM Granite model using IBM/Granite 38B instruct token limits authentication credentials. This code initializes the IBM LLM with the model ID IBM/Granite 38B instruct. Using the provided credentials and project ID, it sets the maximum number of new tokens to 150, which controls the length of the model's response. This prepares the LLMs for our workflow. Defining prompt templates. We define 3 prompt templates: keyword extraction, sentiment generation, sentiment refinement. This code defines 3 prompt templates for prompt engineering tasks. The first template, keyword prompt, is used to extract import keywords from a given text. The second template, sentiment prompt, generates a sentiment summary based on the keywords extracted. The third template, refine prompt, refines the sentiment summary to make it more concise and precise. Each template takes input variables and uses them within a predefined template string. These templates ensure clean, reusable prompt logic. Creating chains. Each prompt is connected to the LLM using an LLM chain. We assign unique output keys, keywords, sentiment summary, refined summary. This code defines 3 chains using the LLM chain class, each with a unique output key. The first chain, keyword chain, extracts keyword from input text using a specified prompt and stores the result under the key keywords. The second chain, sentiment chain, generates a sentiment summary and saves it with the key sentiment summary. The third chain, refine chain, refines the sentiment summary further and stores the final output under the key refined summary. Combining chains. We combine all chains into a sequential chain. This code combines multiple chains, keyword chain, sentiment chain, refine chain, into a sequential workflow using the sequential chain class. The workflow takes text as input and produces refined summary as output and after processing through each chain. This creates a single end-to-end workflow from raw text to refined insight. Running the workflow. We provide customer feedback as input. The workflow extracts keywords, generates sentiment, refines the result, all automatically. This code runs a predefined workflow on an input text containing mixed sentiments about an app's features, customer support, and overall experience. The workflow processes the text to generate a refined sentiment summary, which is then printed. Output. The output clearly highlights positive aspects, negative issues, actionable recommendations. The refined sentiment summary is a concise and clear evaluation of the feedback. It highlights the user's appreciation for the app's features but expresses frustration over frequent crashes and slow customer support, reflecting the workflow's ability to distill critical insights effectively. This demonstrates how prompt chaining distills critical insights effectively. How to choose the right chaining type. Selecting the appropriate chaining type for LLM application involves evaluating key factors to ensure efficiency and coherence. Task complexity. Use runnable workflows for tasks with multiple steps. Few short examples or chart prompt template can help structure complex tasks requiring different prompts. Dependency. If outputs from one step are placeholders for the next prompt, use sequential chaining. Output parsers ensure smooth transition of outputs into structured inputs. Adaptability for dynamic workflows such as those involving LangChain agents, iterative chaining allows real-time adjustments of parameters and next prompts. Data modality. Choose workflows compatible with varied data types. Use embedding methods for text and vector data or LangChain expression language for flexible operations. By considering these factors, you can build a robust and adaptable LLM application with coherent chaining workflows. Summary. The prompt chaining is a versatile and powerful technique for building advanced NLP workflows. LangChain makes it modular, scalable, and production ready. By mastering these chaining techniques, you can unlock the true power of large language models in real-world applications. If this video helped you, like, subscribe and share it with others. In the next video, we'll build RAG pipelines using LangChain. Thanks for watching and I'll see you in the next one. Bye bye.